Welcome back to the deep dive. Today we're exploring an idea that's, well, as old as commerce itself, but maybe with a completely revolutionary angle.
Yeah, the core question is pretty provocative, isn't it?
It is, what if, for the last 5,000 years, our entire economy has fundamentally misunderstood how trust actually works?
Exactly. And we're diving into an emerging technology that claims to flip this completely on its head.
Right, turning what we usually see as a negative, the absence of trust or risk, into something positive, something quantifiable.
A measurable asset.
Precisely. So our mission today is a deep dive into this fascinating tech. It's called Fractal Identity Map, or FM.
And our sources for this exploration, we've got a detailed utility patent application still in draft form, we should note, as of today, July 28, 2025.
Good point. And also an in-depth blog post from its creator, Elias Moosman.
So the big question we're tackling, does FM really challenge 5,000 years of economic thinking on trust? That's the claim.
Yeah, we're going to unpack how it aims to do that. We'll look at the technical heresy it seems to embrace. Heresy, I like that.
It's supposed real-world results, which sound pretty mind-bending.
And the market strategy. They seem pretty ambitious about making this the new standard.
So settle in. Let's get into that central idea. What if our economy has handled trust backwards for 5,000 years? First, maybe let's unpack what that even means.
Okay.
Think about the traditional model, right? Institutions like banks, insurance companies, security firms, even lawyers.
Right. When you look closely, it's kind of striking.
Yeah, their business models often seem to profit when trust fails.
That's a really interesting way to put it, but yeah. Take a bank. Loan defaults. Fees on troubled accounts. That's revenue.
And insurance. It thrives on our fear of something going wrong. Security exists because there are threats.
And lawyers often step in when agreements break down. So yeah, for millennia, commerce has often monetized the failure of trust or the risk of it failing.
And this is exactly where FEM comes in, claiming it can invert that whole picture.
Okay, how?
Instead of measuring the negative, the risk, FEM says it quantifies the positive, trustworthiness itself, making integrity a measurable asset.
Exactly. The creators put it very bluntly, for 5,000 years you made money when trust failed. Now you make more money when trust succeeds. We flip the equation.
Wow. That's quite the statement.
It is. And this leads to a concept from their technical documents called trust debt.
Trust debt. Okay, tell me more.
They say, quote, trust debt has compound interest. If you let it slide, it gets worse exponentially.
So it's not just missing out on a reward. It's like accumulating a hidden liability.
That seems to be the idea, like maybe small compromises in quality control or little delays in a supply chain.
Individual, maybe not a big deal.
Right. But cumulatively, they build this trust debt that could suddenly trigger a massive failure, a recall, losing a huge client.
And the final cost is way bigger than just adding up those small initial problems. It compounds.
Exactly. So imagine if businesses were actually incentivized to build trust equity, something as quantifiable as financial assets.
What would that look like? Like credit card companies paying you for perfect credit, not just offering points.
Maybe. That's the kind of shift they seem to be suggesting. It makes trust an active asset to cultivate.
Okay, intriguing. But how do they claim to actually do this? What's the tech behind it?
Right. Well, this is where it gets really interesting and controversial, apparently.
How so?
FM apparently makes its boldest move by deliberately violating something considered almost sacred in computer science for, 50 years?
Oh, what rule are they breaking?
You know how giants like Edgar, the father of relational databases, and Turing Award winner Jim Gray always insisted on keeping logical data organizations separate from physical storage?
Yeah, that's fundamental. Data independence. So it's like Database 101 allows flexibility, scalability.
Well, FM apparently just ignores that completely.
Ignores it. How?
Their core principle is shape is symbol. The patent states position equals meaning.
Wait, so the physical arrangement is the logical meaning, not just an efficient way to store it, but the meaning itself.
That's what they claim. They say, quote, violating those assumptions was key to the breakthrough. They argue that separation was actually holding computers back from true semantic understanding.
Wow, okay. That is heresy in database terms. So how do they manage data then? Chaos.
Apparently not. At its heart is something called a primary weight ordering engine.
Primary weight ordering engine.
Right. The idea is that data isn't just stored wherever. Its physical location is its meaning, and that location is determined by how strongly it connects to other data points.
So related concepts are physically closer in memory or storage.
Seems like it, like a library where related books are automatically clustered together.
And how do they keep different concepts distinct, prevent them from blurring together over time, which is a huge problem in big data sets?
Good question. They use something called a hybrid orthogonal decomposition architecture.
Okay.
The goal is to keep categories statistically independent. They mention a correlation below 0.1 to prevent that kind of correlation drift.
So maintaining clear boundaries between different types of meaning mathematically.
Right. And then there's another feature they call aware blind spots.
Aware blind spots, what does that mean?
Usually, if data is pruned or skipped in an analysis, it just disappears, right? You don't know what was ignored.
Yeah, it's gone. Or you have to specifically track deletions.
With FEM, apparently, skipped data isn't invisible. It gets its own address and metadata. The negative space, the absence of data or connections becomes transparent and queryable.
So you can ask why a certain conclusion wasn't reached, or what information was deemed irrelevant.
That seems to be the implication. It could be huge for audit trails or understanding model limitations.
Okay, that is interesting.
And they stress this isn't just software. The patent outlines specific hardware structures.
Like what?
Things like a 60-bit semantic address bus, prefix-aware memory controllers, power gating by semantic region. It sounds like hardware designed specifically to leverage this shape is symbol idea.
So the physical layout directly informs the processing, and they claim real benefits from this.
Big time. They cite things like 94.7% cache hit rates compared to maybe 23% for standard systems, and, get this, 55,294 times power efficiency gains.
Whoa. Okay, those are astronomical numbers, hard to even process.
I know. And what's maybe even more astonishing is their claim to have sidestepped theoretical impossibility proofs.
Like the CAT theorem, or complexity bounds.
Exactly. Things like an extension of scikit-P, information theoretic bounds, computational complexity proofs. IFM claims to overcome these because those proofs assume the separation between logical and physical data was mandatory.
So by throwing out that assumption, they claim the proofs no longer apply to their system.
That seems to be the argument. It's like proving flight is impossible by analyzing walking, then someone invents wings. It changes the whole game.
If true, that's a very big if.
Absolutely. Which brings us to the performance claims themselves. They use this phrase, sailing faster than semantic wind.
Okay, poetic. What does it mean in numbers?
It suggests that when information categories stay truly independent, like they claim with their orthogonal decomposition, their positive effects multiply, they don't just add up.
Multiplicative gain.
Yeah, they give specific numbers. 2 dimensions of this independence lead to a 64x complexity reduction. 3 dimensions, 512x. 4 dimensions, over 4,000x.
So complexity doesn't scale with the total amount of data and in the usual way.
Apparently not. They claim FIM scales, with OEE being the hierarchical depth of the data rather than ON or worse. Huge difference for large data sets.
Okay, those are the theoretical claims. What about the real-world results they mentioned?
This is where it gets pretty compelling, if the sources are accurate. They cite high-stakes environments. Johns Hopkins Hospital, for instance.
What did they reportedly do there?
Medical diagnosis. Went from 8.3 seconds using standard SQL queries down to just 23 milliseconds with full audit trails.
23 milliseconds. That's over 360 times faster.
351x, yeah. And they mentioned the aware blind spots feature helped doctors explore rare conditions.
Wow. In medicine, that kind of speed difference could be life-changing.
Literally. But it's not just healthcare. Lloyd's of London, insurance underwriting.
What happened there?
Reportedly went from a 3-day manual process to real-time.
Real-time, from 3 days.
Yeah, a 400x speedup. The source claims $4.2 million in annual savings, and interestingly, 87% fewer discrimination complaints.
Fewer complaints? How does faster underwriting lead to that?
Maybe the quantifiable trust metrics helped remove subjective bias. The source suggests Lloyd's is already pricing AI insurance based on FEM scores.
Pricing AI risk based on FEMRA. Okay, that's a big step. Any other examples?
Supply chain optimization. Query responses apparently dropped from 45 seconds to 12 milliseconds.
That's over 3,700 times faster.
Yes. And the system reportedly flagged nearly 24,000 potential black swan events, those unpredictable high-impact risks.
So predictive power on a whole new level.
And one more. Stanford BCI lab brain-computer interfaces.
Yeah.
Latency reportedly dropped from over 200 milliseconds, which is noticeable, down to under 5 milliseconds. Fast enough for really seamless control and patient-specific tuning.
Under 5 meters. That's
Right.
huge for BCIs.
Opens up possibilities. It really is astonishing stuff. When you hear these kinds of numbers, these speedups, what strikes you the most? How could this change things, practically speaking?
Well, the immediate thing is moving from reaction to prediction. If systems can genuinely anticipate failure, or if complex analysis like medical diagnosis becomes near instant, it's not just faster. It enables things that were simply impossible before.
Right. Limited by computation or time.
Exactly. Imagine interacting with complex AI and it just understands, anticipates, responds fluidly because the underlying semantic processing is so fast and accurate. It could change everything from scientific research to how we manage critical infrastructure.
It feels like it could lead to a fundamental shift in complexity management.
Possibly, which ties into their next big idea, positioning FEM as the, quote, Black-Scholes of AI trust.
Okay, explain that. Black-Scholes gave us a way to price stock options, something abstract.
Right, and FEM aims to do the same for trust in AI systems.
Yeah.
Make it quantifiable, priceable, and therefore insurable.
And they see huge economic leverage in this.
Oh yeah. The source suggests a model where $1 of thumb licensing enables $10 in AI insurance premiums, $50 in derivatives trading based on that risk,
Wow.
$100 in certified AI services, and potentially $1,000 in trusted AI deployments overall. It's presented as a cornerstone for a whole new trust-based economy.
So how do they actually quantify this trust? What are the metrics?
They introduce a few specific ones. There's the integrity score, or IM.
Weird. Yeah.
Yep. A real-time 0 to 100 score measuring how well an AI system is aligned with its intended purpose, apparently used in that Lloyd's pilot.
Okay, what else?
Drift velocity, delta V. This measures how quickly the AI's understanding or performance is degrading semantically.
It predicts failure.
Essentially, it helps forecast a time to atrophy, which is the point where the system loses capabilities irreversibly.
Predicting when an AI might go rogue or just stop being useful.
Kind of. Then there's the cognitive load index, CLI.
Cognitive load for an AI.
Yeah, quantifying how much strain the system is under, how close it is to breaking down. They use it to predict Friday afternoon failures.
Huh. I know those. When everything just seems to fall apart.
Exactly. And finally, blind spot value, VBS.
Ah, linking back to the aware blind spot.
Right. Assigning an actual economic value to the information residing in those unexplored or ignored semantic areas. What's the cost of not knowing something?
Okay, so they have these metrics. What's the strategy to get everyone using them?
It's pretty aggressive. Simple but aggressive.
Which is?
Make AI without FIFIM essentially unviable.
How?
The logic goes, AI systems scored by FIM can be understood, their risks quantified, and therefore insured. Unscored AI. That becomes uninsurable AI.
An uninsurable AI.
Becomes uncommercial AI. Too risky for businesses to deploy, especially in critical applications.
So they aim to create a situation where you have to use their scoring to participate commercially.
That seems to be the strategy. Make it the de facto standard through market necessity.
What could trigger this adoption?
The sources suggest a few possibilities. One company gets a competitive edge using FIM valves. Maybe cheaper insurance, more reliable AI.
Okay, competitive pressure.
Or regulators start accepting or even requiring such metrics for AI safety and accountability.
Regulatory push.
Or a major public AI failure happens, something big and damaging that FIM proponents can point to and say, our system could have predicted or prevented that.
The I told you so moment drives adoption.
Exactly. It all circles back to that idea of trust debt.
Right. Operating without these metrics means you're accumulating this invisible, unquantified risk.
Compounding silently over time.
Until, boom, catastrophic failure makes it very visible, very suddenly.
It's a compelling narrative. But, and this is a big but.
Yes. Let's get into the skeptic's corner, because these are extraordinary claims.
They really are. And the sources themselves, to their credit, point out a major hurdle. The lack of independent verification.
That's critical, isn't it? We're talking no peer-reviewed studies published yet.
Right. No third-party audits that are public. No confirmations from Johns Hopkins, Lloyd's, Stanford about these specific results or deployments.
And that patent application is still a draft, not granted as of today. Searches for Elias Musman or FIM mainly turn up promotional material, websites connected to the creator.
It makes you pause. You have these incredible claims, but they're largely coming from the source itself right now.
Absolutely. And then there's the sheer, Well, the source calls it extreme intellectual hubris.
Claiming to overturn 50-plus years of consensus built by multiple Turing Award winners. Yeah, that takes some confidence.
Or hubris. The default assumption for many experts, probably rightly, will be that FEM's creators missed something fundamental.
That there's a reason the consensus exists.
Exactly, and deliberately breaking those fundamental rules of computer science. It might work in specific cases, but does it come with hidden costs?
Like what?
Potential brittleness. Maybe it works great with clean data, but falls apart with noisy, real-world data. Or scalability issues that only show up at truly massive scale. Unforeseen error conditions.
These are valid concerns when you toss out the established playbook.
For sure. And looking at the economic side, does the trust flip maybe oversimplify things?
How so?
Well, rewarding good behavior isn't entirely new, right? Loyalty programs, preferred customer status, they exist. Maybe FEM is a more sophisticated version, but is it a total revolution?
That's fair. And what about bias? Could these trust scores inadvertently bake in or even amplify existing AI biases if the training data or the weighting is flawed?
A trustworthy score might just mean conforms to the existing biases, a huge risk.
Definitely. And the market strategy itself, making unscored AI unviable while clever, could also be seen as aiming for a monopoly.
Yeah, potentially stifling innovation if everyone has to license femtech to build commercial AI.
So it's a really complex picture. The potential upside is immense, revolutionary even.
But the claims are extraordinary, the independent proof is currently lacking, and the potential risks, technical and ethical, are significant.
It requires a healthy dose of critical thinking. What stands out most to you when you weigh all this?
For me, it's the audacity of the core idea, shape is symbol, challenging something so fundamental in computing. Even if FEM itself doesn't pan out exactly as claimed, asking that question feels important. It pushes boundaries.
I agree. Whether it succeeds or fails, it forces a re-examination of how we handle information and trust.
So, wrapping this up, what's the big picture takeaway? FEMM presents this vision, this potential future, where trust is a tangible asset.
Built on this technical heresy of merging logical meaning with physical structure.
The core is that, quote, shape is symbol. The physical arrangement is the logical meaning. It's not a metaphor. It's the mathematical reality that supposedly allows these seemingly impossible results.
And connecting that back to us, to a listener,
Okay.
It really makes you ask about our current systems, not just AI, but our organizations, our relationships maybe.
Are we building trust equity, or are we slowly accumulating trust debt?
Which side of that compound interest curve do you want to be on? It's a powerful framing.
It really is. And just think how deeply the concept of risk managing the negative is embedded everywhere. In finance, insurance, security, our whole society.
If FIM, or something like it, actually works,
Mm.
could we genuinely shift towards a world where integrity, trustworthiness, the positive side, becomes the main driver of economic success?
Instead of just mitigating the fear of failure, that's a profound thought to end on. Could trust equity become the ultimate currency?
That's a fascinating possibility to consider.